Okay, in third module, we are going to see the next topic, that is an efficient approach to sorting in memory. So here we'll be mainly dealing, or we'll be discussing about heap sort. Okay, so here we first itself will understand what all is actually mainly done in this heap sort. The first process which is done is we read the data from the disk to the memory. First step. The second one is, after that we do the sorting. We can do shell sort or any other sorting and sort the data. And after that we have to write the data into my disk. Okay, we can tell that these three process steps are very lengthy and it takes more time. For fastening up the process or improving the process, we can decide to do these three steps parallelly. Okay, now how can we do it parallelly? For doing it parallelly, you can either do reading or writing and sorting at the same time. In that case, these three steps can be reduced and it can be done within less time. So in heap sort, how can you do these steps parallelly? For doing that, first itself, we'll do the building of the heap by whenever we are reading the data from the disk, and we try to do the sorting whenever we are going to write the data, the sorted data into the file. Okay, so these are the main two steps. How is it done? By using heap sort. Next is about here in heaps we have as similar to a merge sort, we are having selection trees. It is a tree in which the data are being compared and the winner has been chosen, as similar to our merge. Okay, here the three important points which you have to keep in our mind is each node is having a key, and it is checked whether it is greater than or equal to the parent node. Okay, if it is greater than or equal, according to that condition it is placed. So here in the textbook we are mainly dealing with min heap. Since it is min heap, we try to maintain our parent less value and our child having greater value. Okay, so always the node must be having less value compared to our the node must be having greater value compared to a parent. So parent must be having less value. So we can tell our heap is always a complete binary tree. Complete binary tree in the sense the levels will be balanced. Okay, and here when you do about the storage of heap, we are having two things. Okay, if the parent node is node I, then the child node will be placed in the array in location 2i, that is the left child, and the right child will be placed in 2i plus 1. So in this case there is no need of a pointer. We just have to do the calculation and allot the value in 2i, that is the left child, and 2i plus 1 hold the right child. Okay, so this is how it looks like. Now compare that, consider that we are having an example A B C D E H I G F. Okay, here I am placing the parent, as I have already told, is a min heap. A is the first child, and the next it is as usually kept in the first location, and in the array also in 1. When you come with the second one, B, it should be placed, we'll check whether it is greater than our parent. Okay, if it is greater than parent, it should be placed in the 2ith location, that is the first left and then the right. So if a left child means 2 into I, 1, that is 2 into 1, that is 2. So in the second location a B will be placed. And next is 3. So next is C. Now when I consider C, C is again being checked with the parent. It is greater than, so where we have to keep means in the right side of A. So for that we'll do 2i plus 1, that the value is 3. So now C is kept in 3. Similarly for B also. Whenever we go to add E, what happens means we check with the parent whether it is greater. If it is greater, we place it first in the left node. For calculating the left node, what do we do means E means fourth location means finding the parent of it, 4 divided by 2, that is 2. So 2 is a parent. Then in 2's left side I should place E. So it is 2i 2. Okay, 4. 2i means I is now 2. So fourth location I'll place E. Similarly for every other. Okay, so this is how the min heap placement works. Okay, next is, so this is the algorithm of how the elements are placed. As I have already explained, number of elements is the number of elements to be placed in the heap. Maximum element is the content of your the maximum elements in your array. then it has always been incremented before you add a new key. First itself, whenever you do the addition, it is added to the nth location of your heap array. And after that, we do the comparison with our parent. For finding the parent, what we do means every new node is having a location k. So new element will be having location k, and we are having a variable called parent which hold the location of your parent. So here whenever k is greater than 1, that is the child is greater than 1, what do we do means for finding its parent, we do parent is equal to k plus by 2. So now we get the parent. Now what we have to do means we will do the comparison between the child value and the parent value. If the new value is greater than the parent, in that case it can be a child of my parent. Okay, in that case it will break and it will place the value. Okay, it will place in 2i or 2i plus 1. If it is less than, if the new node is less than that, what we have to do means we have to exchange the parent and the kid so that the minimum comes on the root. So the parent will be the minimum value. In that case we go for exchange, exchange k and p, and then after that we place k is equal to parent so that the parent becomes a smaller value. This is how the algorithm works. Now here the next one is building the min heap while reading. So as I've already told, in heap we try to do building the heap and sorting the heap parallelly. Okay, so building is done whenever we are reading it, and sorting is done whenever we are writing it into the disk. So here main point which you have to keep in mind is each time we read a block, we'll add it to the heap, we'll build it, and after that we do the sorting and write it to the disk. Next is an example of telling how is it being placed. Okay, similar to our previous example, this is another example for making the point clear. Here f is the first node to be placed, so f. Okay, here it is the first node and the parent is itself f. Okay, and d. In second one is d. In when d is come first time, it is placed inside second location and the parent is f. Now we are doing the comparison. So when we do the comparison, we come to know that d is lesser than f. So what we have to do, we need to do swapping. So when you do the swapping, now d will come in the first and 2 will come in the second position. That is why we have d and f in the first and second position after the swap. Similarly for c. Now c has been inputted. Now when c is inputted, c comes in the third location. Now we'll 3 divided by 1, 3 divided by 2. Divided by 2 means the parent is 1. So when you do the value comparison c with the d, c is lesser than d. In that case, we have to do exchange of values. So we go for doing swapping of c and d. So now c becomes in first location and 3 becomes in d location. So that is why we see the swap here cfd.